Okay. All right. So the directions for put that away. Are you doing the feedback form?
I was trying to like confirm.
All right. Hurry up. Hurry up. All right. Now on your feedback form, you can say I beat you. Okay. Now we're going to find all of the intervals where we are, let's say, decreasing. We could also do increasing. I'm just going to pick decreasing. We're going to write all of the intervals where we are decreasing. So the first thing I would suggest that you do is look at the picture. Decreasing means going down. So would you agree that this part of the picture is going down? And this part of the picture is going down. And that's it. Right? Those are the going down parts. So now you're going to have two intervals, my two red intervals. They are going to be from here to here. Now, when you write the interval, you use the x coordinates. We're going left to right, so we're looking at x coordinates. So what is the x for this? What is the x for this? There's your first interval. All right, over here. What is your x for the beginning of this right here? And your ending. And that's it. If we were doing the increasing intervals, we would be looking where our pencil goes up.
Will there be stuff like that where those are like filled in dots or open dots?
Actually, increasing or they're all closed dots in this picture. Increasing intervals means where is the curve going up, or in this case, decreasing down. Well, at a specific point, the curve isn't really moving.
Yeah.
So that's why we don't generally include them. If you include them, I certainly would mark it wrong. I think this is going to be a multiple choice question probably.
Okay.
So I wouldn't, but if it's not, if you include them, I'm not going to mark it wrong. It's kind of a fine. But remember, what goes in the interval is the x's, because we are moving left to right on our picture, right?
Even for the increasing, it's still the x's.
Always x's. Always x's when you write an interval. The only time you use y's is in range. Otherwise, we're always looking at x's. All right, I think we did one of these the other day. Maybe we didn't, but we didn't do it with an imaginary number. Now, that doesn't really change anything. If you're going to find h of 2i, what are we going to do? Plug in 2i. So we're going to have 2i squared minus 2i plus 3. Please remember PEMDAS. When you look at something like this, you square before you multiply. So this is going to be 2 times 4i squared minus 16i plus 3. So 8i squared minus 16i plus 3. Does that look okay to everybody? Check and see if I'm missing here. Okay. Now, what do I know about I squared? So this is actually negative 8. So it looks like I have negative 5 minus 16i as my final answer. Again, no big deal there. The other day when we did it, we didn't have i's, so I thought, let's put one in here with i's. Okay? All right, and then we've got this monster. Now, lots of questions can come from this. This could be either multiple choice questions or this could be a huge free response thing. Let's ultimately graph it. But in order to graph it, there are lots of things that we need to find. Remember this kind of deal? You have asymptotes, poles, intercepts, all kinds of stuff, right? So what do we do first? All right? Factor everything. Factor everything, middle factor. So, okay, factor everything, middle factor. So I'll take a 2 out of the top. And then I can factor that, x plus think I have factored correctly, but double check that. I made a mistake on a problem like this earlier today.
I think that's right.
Is that right? Now, first thing you notice, hopefully, as you're doing that, is what? You're gonna have a hole because this is gonna cancel out. So what I'm actually going to graph is 2 times x plus 3 over x minus 2. So a multiple choice question could be, okay, here's your thing, where's the hole? All right, where is the hole? Well, it's gonna be where x is negative 2 and y is where? I gotta put in negative 2. Do you get negative 1/2? So if I'm graphing, I'm gonna have a hole at negative 2, negative 1/2, open dot in my graph. The hole comes from what cancels out, right? Right? Okay. Now what else? Well, if I was graphing, I guess I would need to know where my asymptotes are. So where are the asymptotes of this? Remember, this is what you are looking at now. What do we know about asymptotes here? Now, if I plug in 0 for x, I'm not finding an asymptote, but that's an important thing to find. But what is it if I plug in 0 for x? That's my y-intercept, which is okay, we can put that on the graph, but that is not an asymptote. The y-intercept, I put in zeros, so I get 6 over negative 2, I got negative 3. My y-intercept is negative 3, which is just my y-intercept point on the y-axis.
Would you have a horizontal asymptote at y equals 2?
You would have a horizontal asymptote at y equals 2. Eli's looking at the problem and saying, look right here. Doesn't that tell me that my horizontal asymptote is at 2? Remember, you look at the highest power? So it's possible, I think the one you looked at yesterday, or I looked at with somebody, the problem was like 5x minus 2 over x squared plus 7, something like that. Now that horizontal asymptote would be at 0, because there isn't an x squared on the top to compare with the one on the bottom. So that would be at 0, y equals 0. This one, because they match, the powers match, I can do y equals 2.
When do you do synthetic?
When the power on the top is bigger. And that would not generate a horizontal asymptote, that would generate a slant asymptote. Your horizontal asymptotes only exist if the powers match or if the one on the bottom is bigger. If the one on top is bigger, you'll have some kind of a slant. All right, so what else do I know? I need all my asymptotes here. I found, or somebody found, the horizontal asymptote. Where's the vertical asymptote?
2.
It is also at 2, but I'm going to be real careful and label that as a line, x equals 2. Now, somebody found the y-intercept. Where are my x-intercepts, or is my x-intercept? Where, Lauren?
X plus 2.
I look,
X equals 2.
actually, the x-intercept comes from the numerator. So my x-intercept is going to be at negative 3. Remember, Lauren and everybody else, an x-intercept is the number you plug in to get 0. So if I put negative 3 in here, then I get 0. That's what an x-intercept is. It's called 0, because it gets you a 0. So, again, that problem could be given and you could be asked a ton of different questions. We've answered all the questions now. We have our asymptotes, we have our intercepts, we have our holes. So now, if we have to sketch it, now we just connect the dots, right? not forgetting that there's another chunk up here. Right? Charlie?
How do you find vertical asymptote?
Denominator can't be zero, they are cannot be's. Cannot be's, denominator cannot be zero.
Can we do a slant problem?
We can after I've answered all the questions about the review sheet, okay? Okay? All right, so we good? So these are the three I want to throw out. Now I want to answer any questions from your review sheet. Remember, we eliminated some of the questions because we haven't covered that material. So I had to circle those or cross them out or something the other day, so I don't want to talk about those. But any of the other things that you studied and have a question about. Nyla. Yep. So number 8 on the big review sheet. This is a calculator problem. How do we solve it? Log both sides, absolutely. We're going to take the log of both sides. Then the exponent comes out in front. Remember, that's the beauty of logarithms. That's why we like them so much. And then I can solve. I'm going to solve for x. I need to get it by itself. So what do you think might be the first thing I would do?
Divide by 1.
So 2x plus 1 is going to be log 8 over log 11. I'm going to divide both sides by log 11. And then what am I going to do? Subtract 1. So 2x equals log 8 over log 11. Subtracting 1. And then I will divide by 2. I'm not going to write that down because it's going to look really ugly and scary, and it's not scary. I'm just going to type in log 8 close parentheses divided by log 11 close parentheses equals minus 1 equals, and then divided by 2. Divided by twice. Alright. I got negative 0.066. Anybody else get that? I hope you're typing in with me. Alrighty, I graded some papers this morning. It was obvious kids were.
Thank you so much.
Okay, alright, so what else? Who else has one? Meg?
Number 29 on the,
Big review. 29 says, this is another calculator problem. If Nate is 1 minute late, he gets 1 detention. 3 minutes late, he gets 4 detentions. 4 minutes late, 11 detentions. Write a quadratic equation using the quadratic regression capability on your calculator. Alright, so what does that mean? I've already, anytime it says regression, whether it's cubic, exponential, whatever kind of regression you're doing, you need points, right? Because the points are going into stat edit. They're going in as list 1 and list 2. So once we get those points in, stat edit, list 1, list 2, got them in. Then, what do? Go back to stat, over to calc, and then pick the regression that you want. This time it's quadratic, so we'll pick that regression. And it looks like my equation is 1.83 x squared plus minus 5.83 x plus 5. Now, let me just say, this problem is totally made up, and so it's not going to make sense, okay? For illustrative purposes only. I was trying to get cutesy. I had a kid that year that was late every day, so I thought I'll put him in the problem here. So the answers aren't necessarily gonna make sense, but it's all about process here. So step one, organize your data into points, okay? Step two, stat edit, put those points in. List one, list two. Step three, back to stat, but this time choose calc. Go down to quadratic regression, and it should give you this equation. So this is the equation for part A. Now, part B says, how many detentions will he get if he's 5 minutes late? Well, what am I going to do to figure out how many detentions? Remember, this was minutes and this was detentions when I set up my points. So how am I going to figure out how many he gets?
Filling at a 5 for X.
Yeah, isn't 5 minutes? So I'm finding this, right? How many detentions go with 5? So I'm just gonna plug 5 into my equation. So 1.83 times 25 minus 5.83 times 5 plus 5. And I got about 22. I got a decimal, but since it's detentions, I'm just gonna say 22. And then it says, what is the minimum number of detentions that he can receive? Well, let's not lose sight of the fact, what is this? That's a quadratic, which means it's what shape? That's a parabola. And it opens up. So if it's a parabola opening up and I'm interested in the vertex, or the minimum, that's the vertex, right? Don't I just want the vertex? So I had a calculator, obviously to do this problem. So could I graph that and then find the minimum? Absolutely. There are other questions on the examiner that are not calculator, where we have to find the vertex. So let's go ahead, math isn't that bad. So x equals, how do I find the vertex by hand? Negative b over 2a. So the x coordinate is going to turn out to be about 1.6. And again, this problem isn't making sense because I made it up, but that would be the x coordinate of the vertex. How do I find the y? Just plug that in exactly the way I plugged in the 5, only plug in 1.6. So again, if you have your calculator and you need a minimum or a maximum, go ahead and graph it, that's fine. If you don't have a calculator, then you need some other kind of mechanism to do it.
Can we do number 1 in the semester 1?
Yeah, are we good on this now, people? If there's something I did that you don't know how to do, you need to come to office hours in the morning or find a friend. Oh, not familiar with you. Number 1. All right, we have to solve this equation. We're looking at number 1 on the big with you. We're solving this equation. So what is the first thing you probably want to do? Probably want to factor that last one down there and then make all the denominators match. Okay? So looks like my common denominator is going to be this right here. So this one needs an x plus 1. This one needs an x, and that one doesn't need anything. Now be careful, this is a 0, so we're lucky, but if it were any other number, you have to do it over here too. since it's a 0, it doesn't matter. But if it's a 1, then you have to do that, okay? Now, as soon as they all match, then you can get rid of them. So it looks like I have this, which is x squared minus 2x minus 3 minus 3x plus 3, that's a FOIL, I foiled it in my head, equals 0, I hope I foiled it right. Alright, so what have I got? X squared minus 5x equals 0. Oh, new markers, I think I'm getting high up here. Alright, now what? Factor, take out an x minus 5. So x equals 0 or x equals 5. These are the ones, though, that you have to be really careful. 0 is extraneous. Because what happens if you put a 0 into your original problem? Doesn't it make your denominator, one of them, 0? All of them, actually. So that's out, and the only answer is 5.
I'm not sure if this one was supposed to be crossed off or not, but on the back of that paper, number 24.
Oh no, 24, you have to know how to do that. You know how to do geometric equations, we did those. So a function is defined parametrically. Okay. First question says, find the point, these are x's and y's. Find the point if t is 0. Well, that's easy. If t is 0, x is -1 and y is 3. Alright. Could we find other points if we needed to? Could we let t be 1 and 2 and -1? Yeah. So you can create, this is the point when t is 0. If you need other points, you just plug in other t's, and that would give you other points. Alright, write the Cartesian equation by eliminating the parameter. T is called the parameter. Cartesian refers to x and y. Remember, the official name of this is the Cartesian coordinate plane. So we just want to write an equation. Instead of having 2, we want 1, and we don't want any more t's. We want just x's and y's. Eli? Is it an emergency? Leave your phone here. All right. How do you suggest we do that?
You set it up where the 0 equals, in parentheses, y minus 3 squared minus 1.
Okay, so we're going to substitute. So t, we're going to solve for t. So t is y minus 3. And then, yeah, we're going to take that y minus 3 and plug it right in there. So it's not 0 equals, it's x equals y minus 3 squared minus 1. So we could eliminate or substitute out the t. Since that's a square and that's not, I need to eliminate, but I need to substitute. So I'm going to get t by itself and then plug it in. Now I have an equation, and the only variables are x and y. That's it. That's what the job was to do. So I've done that. Part B, done. Now, part C says sketch this. So you probably have different comfort levels with this. What would you do if I said sketch this? What would that look like? A parabola with a vertex at 3, -1, right? Opening up. What do you think happens? Same kind of equation, but I turn the variables around. What do you think happens? We get a parabola that opens on its side. Instead of opening up and down, we get one that opens sideways.
Does the vertex stay the same?
The vertex is -1, +3. remember, points are always x comma y. Y is 3. So x is -1. So your vertex is at -1, +3. And it opens to the side, to the right. Now, if you're uncomfortable with that, I get it. I mean, we haven't even studied anything that's not functions yet. So if that confuses you, okay. What you'll do is, remember what I told you back here? What was the very first thing we did? We found a point by letting t be 0. Oh, by the way, look what that point turned out to be. Okay, there's a point. So if I want more points now, I'll let t be other things. So if I let t be 1, I would get 0, 4. That's this point right here, 0, 4. And so if I can't tell from my equation what the graph is, just make up some t's and plot them. Plot all the points till you get a picture that you can connect the dots. Okay?
Did you make up x's too, or do you have to?
No, you make up t's. You make up t's. Now, oh, I see what you're saying. What you're saying is, could I put things in here? If I were going to do that, I'd put in y's. It's going to be a lot easier to put in a y and figure out an x. You could do that. Yep.
Could we do, for D, it's on the additional examiner, do you want that?
For
D.
this is another set of parametric equations. What am I doing this time? I'm finding the y-intercept. Okay, how do we find a y-intercept of anything in the whole wide world? Let x be 0. This is like 4 exam questions, you guys. 4 problems involving y-intercepts. How do you find a y-intercept? You let x be 0. I don't care what the equation looks like. It doesn't matter. So I'm going to come up here and I'm going to let x be 0. Well, what does that tell me? That tells me that t has to be 3. And if t is 3, then what's y?
11.
There you go. What's your y-intercept? 11. You let x be 0. Done. That's how you do it. Every x-intercept in the whole wide world. Y-intercept. Every y-intercept in the whole wide world. Let x be 0. All right. What else? What else do we have? We still have lots of time. Brandon?
Can we do 25 the second problem? The one on the right.
So we're solving a logarithmic equation. Who has a thought about that? Robbie?
The second equation, you move the 2 up and you square the 8.
So remember, yes, the coefficient in front of a logarithm is an exponent. So this says the log of x equals the log of 64. Wait a minute. If log equals log, what am I allowed to do? Drop them out.
I thought it was 1/3.
Oh, is it 1/3?
I think it is.
Yeah, it is.
Where am I?
You're on the right equation. It's just the first
Oh,
one.
no, it's not a 1/3. It's got the blob on the paper.
Okay.
Yeah, I am not gonna give you anything where the bases don't match. That would be cruel and unusual punishment. It's bad enough when the bases do match. All right, Karen?
Could you 14 on the bigger view?
So we have some kind of polynomial out there, and we know that 1 and 2i are the roots or the x-intercepts. These are the x-intercepts. That was kind of hard to be x-intercept and imaginary. These are the roots of the equation, and we have to build the equation. Well, the first thing you got to remember is you will never have 2i without also having negative 2 on it. So that has got to be included in this, okay? Second thing you need to do is think about all the equations you've solved in your life. You go down through, and at the very end, you got x equals 1. What was the step right before getting x equals 1? X minus 1. That was your factor, right? So these guys all correspond with factors. So to get the equation, all we have to do is multiply the factors together. And I would always, it doesn't, in the end it won't matter, but I would always start with these because they're conjugates, and when you multiply, things are gonna cancel out. So it's gonna be easier to deal with. So just FOIL them out. Remember, we talked about this already today, what's negative 4i squared? Plus 4. I know, they're hideous.
Yeah, I can smell it from here.
I'm sorry, imagine being right here all day smelling this marker.
You can't smell it.
No wonder I'm cranky. Here we go. This is my polynomial right here. Okay? Got it? All right. What else? Katie?
Can we do 18? Understand what it means by writing on the same page?
It means unloop-de-loo it. So you have e to the 7 equals x. That's log base what? Go the other way. If you had log base 8 of 9 equals x. If you had that, that would become 8 to the x equals 9. Agreed? So now go backwards. You have this and you want to have this. So what's the base? E. Gonna put an x here, and it's gonna equal 7. Just play around with the numbers and make sure when you loop-de-loo it, it gives you what you want. That's the logarithmic form. These two equations are exactly the same. That one is exponential, has an exponent. This one is logarithmic, has a logarithm. Okay?
Why wouldn't you do ln and cancel out the e?
You could write this as ln x. It doesn't cancel out the e. Log base e is ln. So you could definitely write it that way. Yep.
Can we do 15 on the same page?
Okay, we kind of did this already too, but it was written differently. This says, we've got a couple of functions.
Not ready to do it.
And I need to find, I'm just gonna do the first one, I need to find g of f of x. Okay, so what does that mean? What do we mean by finding g of f of x? Plug f of x into g. It's a composition. So f of x is 2x squared plus 7x minus 1. So I'm going to plug that right here into g. So 3 times 2x squared plus 7x minus 1 minus 2. I took the f function and I plugged it in to g. Don't get psyched out because it's big. If I said find g of 2, what did you plug into? So when I say find g of anything, you just plug that in. So you got 6x squared plus 21x. I'm just going to say minus 5 because that's going to give me a minus 3 and then a minus 2. So if it were the other way around, which that was the second part of that, if it said find f of g of x, that means that you plug g into f. So f of g of x would be f of 3x minus 2, which means 2 times 3x minus 2 squared plus 7 times 3x minus 2 minus 1. You see that? That's going the other way. It's always this one into this one. Now, when you simplify this one, please be careful. This right here is a FOIL. Please don't distribute. Don't square. No, it's a FOIL. So you gotta do 3x minus 2 times 3x minus 2. Right? And then distribute the 2 out here. Alright? Charlie?
What would you do for 16?
Huh?
What would you do for 16?
16?
Yeah, the one right there.
Find the inverse. How do you find an inverse, Charlie? We need to know this. What function am I using? This one right here. How do I find an inverse? Switch the x and y. So I would rewrite my thing as x equals 3y minus 2. And then solve for y. Get y by itself. Solve for y. So x plus 2 equals 3y. Y equals x plus 2 over 3. So that would be my inverse. So what are the steps to finding an inverse? Switch x and y and then get y by itself. Right? Yep. All right, who else? Okay.
Number 2 on the additional exam here.
Find the symmetry. Well, to do this, you have to remember your tests of symmetry. Remember, we have x-axis, y-axis, origin, and identity. Those are the big things that we can have symmetry about, or with respect to. So to do the test of symmetry for the x-axis, we change the sign on y. And then we stand back and look at that and say, is that the same equation as the one I started with? And the answer is, well, no, it's got a negative in front of it, okay? So we have no symmetry to the x-axis. For the y-axis, we change the sign on the x's. Now that one will require me to simplify a little bit, so let's see. Does that match my original equation? Nope. So I don't have that one either. These are those no's. To test for symmetry with respect to the origin, I change the sign on both. And clean it up. Oh, wait a minute. I think that one matches, doesn't it? So we do have symmetry about the origin. For the identity line, I switch the variables completely. And obviously that doesn't match the original. So this one has symmetry about the origin. What do we call that? When something has symmetry with respect to the origin, it is called what kind of a function? Odd, odd, odd. Remember you have odd and even? Odd has this symmetry, odd origin. And then what's the even one? Even is when it has symmetry with respect to y-axis. Yep.
Identity and inverse, will they use like on that one before that where it said find, or it didn't say it, but it was find the inverse. Could it be find the identity?
The inverses have symmetry across the y, at y equals x, the identity line. So yes, they're really closely related. All right, who else? What else? Come on. Extrema mean high points and low points, critical values, maxes and mins. So like, if you're looking at your absolute value function, it has a minimum at 0, 0. That's its extrema. Maximums and minimums. Not everything has maxes and mins, right? Like, a logarithmic function doesn't. A logarithmic function is like this. There's no hill and valley in there. Extrema, you got hills and valleys. Lauren?
Can we do number 4 on semester 1 review? Like the number line.
Yep, that's. Kind of an easy one here. Well, I should say it can be done easily and it can be done hardly. I'd rather do the easy way. My job is to solve for x. So what do I need to get rid of? To get that x by itself, I need to get rid of the, I need to get rid of the 8 first. So I'll add 8, but when I add it, I have to add it in all parts of the problem. So now I have this. And then I will divide all parts by 4. So 3 halves less than or equal to x less than 7 halves. Now, remember, the test is multiple choice. Problems like this are going to be multiple choice. So that may not be an answer. The answer may be written in interval notation. So it would look like this, right? But that's the same answer. It's just written differently. Okay, so when you do your multiple choice, maybe it's not written exactly what it came out for you, but find the answer that does mean the same thing. Okay?
So like we would have to do like a number line back to this one.
You don't have to with this one. You can if you want, but that makes it so much harder. So I wouldn't. You could split this up into 2 inequalities and figure out where they intersect. Brady?
Are there any number lines on the final? Like, do we have to like?
There will be problems that involve number lines on the final, yeah. Now, I honestly, I don't remember saying, graph your solution. We're a little old for that, probably. So just find it and move on. Some of the problems require you probably to look at a number line, and figure out, weird shape, like this quadratic inequality. You have to, solve this. You're gonna have dots on the number line, 2 and -3, and then you have to figure out where shade by plugging in numbers or something else. Okay?
How many questions are final? Like, would you, like, 100, 150?
I mean, there's enough, I don't know how many there are. People always get done. The time is not an issue, ever. I mean, I want you to take your time, but you will be fine.
We have second one.
Again, Meg, I don't get up every morning thinking, how can I destroy your life? I want you to pass, I really do. All right, I had a question a minute ago, I need to do it, I can't remember what time to get out of here. But I need you people to know. Somebody said, do a problem with a slant asymptote. So one of the first problems we did was a big thing, and we had to graph this. So remember, we had asymptotes, intercepts, holes, and all that. This problem, I can tell immediately, has a slant asymptote because the power on top is bigger. So to find the slant asymptote, I'm just going to do the division the regular, division of the problem, hopefully I did that right. And then the asymptote, that's the remainder, get rid of that. The asymptote is at the quotient here, which is 2x plus 2. So that would be the slant asymptote for that problem.
If the bottom, like the one on the denominator had a higher power than the one on the top, would the asymptote just be y equals 0?
Yeah. Yep.
But I have a question about the number one straight at the end. You're trying to shade it with just removing it.
And see if they work, you shade that part, if they don't work, you don't shade it.
Is there anywhere we can only do long division, or are we always able to do synthetic?
I think you're always able to do synthetic.
Okay.
I mean, I think when we took our test, we had synthetic.
Yeah, that's what I think.
All right, what else? Listen, 24 hours from now, there's gonna be complaining and whining and moaning. I wanna avoid that. What do we not know how to do? Eli?
I don't know if anybody's already said it, but number 5,
On what?
semester 1.
Okay, we crossed that one off.
Oh, we did?
Yeah, we did. We crossed off several. Well, I don't know about several. We crossed off a few. Charlie?
We do, 26 on, additional geometry on the left side.
So we're sketching y equals 3 to the x plus 2. What does an exponential in general look like, Charlie?
It's like this.
No. Gotta know our BFFs. Okay, this one happens to be an exponential, but we could do this with a logarithm or anything, right? So that regular exponential looks like this. It goes through the point 0, 1 and has an asymptote at 0. That is your basic. Now, what are we doing in this equation? We are adding a 2 directly to the x. So what does that do to any picture? If you add a 2 directly to the x, it's going to move you 2 units to the left. This moves you 2 units up. We are going 2 units to the left. So that isn't going to impact the asymptote. That point is getting shifted over, so now it's at -2, 1, 2 units to the left. And that's it, just 2 units higher than it was before. Still got the same asymptote, so it's still getting close out here. Okay? Mm-hmm.
So, when you say like 150% graph,
Oh, it's a 2.
So when you graph polynomials, so we could graph it like x plus 2, x plus 4, x minus 3. If we graph that, we know we have intercepts at -2, -4, and 3. Right? And every time we graph one of those, I would ask a question and say something like, okay, are there any bounces in this problem? And you would all look at it and say, no, because there aren't any squared factors, right? So when you do it, you just connected all the dots and that was it. That was the picture. Well, how does that change if we put a square right there? Well, now my intercepts are at -2 and -4. But now, when I say, are there any bounces, you say, yes, it bounces at -4. So it comes up from the bottom, just touches and bounces off. We call that a point of tangency. Remember when you studied geometry, you called that line a tangent line because it just touches. That's what's happening here. You're just touching, bouncing off. So where is the point of tangency? Wherever you have a squared factor, because that's going to be a tangent point, right? You're going to bounce off. See?
How do you know if it's, like starts at the bottom and ends at the top?
What the degree of the polynomial is.
The highest one?
No, the total degree. So this is, if I FOILed all this out, it would be x cubed. X cubes start down and end up, all odds. X to the fifth, x to the seventh, that's how odds do. Now, that doesn't impact whether you bounce or not, because anything can bounce, but that impacts how you start, where you start. So evens, x to the fourth, up. Now, of course, all that changes if you stick a negative out in front, right? All that changes. It's upside down. Nothing is hard, but there's a lot. A lot. All right, what else? We're not quitting. If you think we're quitting, we're not. We've got, everybody wants to do really well tomorrow. I graded several, another class obviously, but I've got some really good papers. And I've got, yeah, I don't want any of those out of this group. Warren?
Can we use 30 on the big review?
Consider the exponential function. That's that one right there. Let me just read this part. So this is your exponential function right here. This is what it looks like. What's its domain? What are the x's for this picture right here? What are the x's? So negative infinity to infinity. What's the range? Be careful. What's the range? 0 to infinity. And 0 isn't included because it's an asymptote. Would you say that's continuous? Yeah. Can't I draw it without lifting my pencil? Yeah, that's continuous. Does it have any asymptotes? Yes, it has a horizontal asymptote at y equals 0. Would you say this function is increasing or decreasing? Increasing. Now, there are some functions that are both. You think about your parabola, for example. It's decreasing on this side and then increasing on that side. This one is decreasing the entire time. Is this bounded? Yep. Not above. That arrow is going up forever, but it's bounded below at y equals 0. It does not go below 0. And what is its end behavior? Well, the end behavior, remember, is what happens in the extreme left and extreme right of the picture. So as we go right, following our curve, as we go right, what is my finger doing? Going up forever and ever. So your end behavior on the right is infinity. It's just shooting up into space. But what's happening to my finger now as I go to the left? It's getting closer to 0 from the top. It's coming in from the top, but it's getting closer and closer and closer to 0. Okay? Now, you should be able to do something similar to that with your main GFFs. Now, not something weird like the sine or the cosine, but the parabola, the absolute value, cubing, you should be able to do something like that.
If we ever parabola and it's like
You say it's increasing
from like a certain point.
from negative infinity to 0, it's decreasing, right? And from 0 to infinity, it is increasing.
And then it adds extrema.
Extrema are, somebody already asked that, extrema are maxes and mins. High points and low points, gotta have a hill and a valley. So the exponential has no extrema. The parabola has a minimum equorigin. Right? Low point. All right, one more question. One more. I need one final sniff of my marker.
Can we practice the vertex for 5D on the additional exam review?
We already did that one. We did. Well, maybe it wasn't this class. Maybe all my classes were together again. All right, if I move that 3 over, it's in vertex form now. I just add that 3 to the other side. So where's the vertex? So if they're in vertex form, you just add it. If they're not, negative b over 2a. That's the way to go. Okay, we're gonna have prayer. I need to. So we're missing. Whoa, where's Drew? Has anybody seen Drew today? All right, so let's wait for the prayer. I suppose the schedule tomorrow is just like today, so will be the lunch period, but we last. So we'll take our exam and then we'll go to lunch. Sit down, Robbie.
It feels weird to have lunch in
I know. I don't know why they did that. It seems like you could have had the exam and then had lunch. I don't know. Yes.
We're supposed to.
So you'll take your B exam and come immediately here and take your C exam. All right, let's do prayer. As soon as someone prays, we can leave. Bye. I'll see you tomorrow.
Bro, what would this
Positively or negatively impact one's life. Bro, no.
All right. Mari, sit down.
I hate you. I swear, like I knew that.
Get your calculator out. Go.
Bye.
Bye. All right, and there's an email from you. You did the survey. So give me this. Cross that off. you're supposed to come to office hours.
Sorry.
Go ahead, I'll answer your question.
I was just confused on like what like you use to do long division. Like if it asks you to do
Can you
like
show me the review problem?
yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, that's what they. So we're going back to that one. Add to that. 19. Today's Thursday. You can do that synthetically.
Is that the crow's nest one?
That might be what he calls it, I in the box for little -2. And then for a -4, 1. Yeah, that's it. And then this number 9 is gonna be the remainder, whatever.
Oh, okay. And then if you like how do you know whether to use that versus the like long division?
Okay, you would never use long division unless what you're dividing by is like x squared. So I can't think of problems we've done. I think everything we've done is synthetic because it's easier. You can do long division, but it's easier and less paper to do.
Okay. So then you just would use the crow's nest for that thing. Okay.
Yeah.
Thank you.
I'll be here in the morning for office hours.
Okay. Sorry about that.
That's okay. My kids will be here too.